Good day, I'm Maile Matsiba. Welcome back to our channel. We continue with our 2017 study guide of our CIR 113 module. We're looking at example 5.1.4. It says a milk supplier can buy full cream milk which contains 6% butterfat for 330 cents per liter. He can also buy the no-fat milk which contains 0.6% butterfat for R180 per liter. He wants to market a low-fat milk which contains 2% butterfat by mixing the two raw materials and packaging the product in plastic containers. All these percentages are on a volume basis and mixing is ideal. Now the question says the cost, or it goes further to say the cost of mixing and packaging is 80 cents per liter of milk. What should his selling price be if he wants to make 130% profit based on the combined cost of raw material and packaging? So yeah, that is actually the problem statement. The question is, how much must his selling price be? And there's a diagram there. So when you attend into such a question, it's important to understand that it has two parts, not necessarily steps, but two parts. The first part is actually the chemical engineering, where you need to figure out the volumes and the capacity of every single thing. And after that, after you got the right answers of the volumes and all that chemical engineering stuff, then you get to calculate, based on that information, you get to calculate the finance attached to it. So yeah, so we're going to be starting with the chemical engineering part. We're going to be doing a chemical engineering work, and then we'll see the finance just after we sorted out that. So the first thing to do, as usual, is to choose a basis, and it's always wise, it is easier to actually choose 1 liter of this volume. So we can just say it's 1 liter. Yeah, the full cream milk is actually 1 liter. But now if this is 1 liter, we know that this and this milk and this milk is gonna mix and to give us that one. But now it means we need to know how much of this, and we can just define this as X and also this one as Y. So the no-fat milk is X and the low-fat milk is actually Y. This is actually going to help us in calculating the volume of the X and the Y as we're going to be doing the equation. Let me just write it down. Basis 1 liter of full cream milk. So that is actually let me just write with 6% butterfat, and then this one we can define it as X. You can see, let X be the no-fat milk, with 0.6%, and Y be the product milk, which is the low-fat milk with 2% butterfat. Yeah, so we've defined both our X and Y. So now with this said, we go to our first step. So the first thing we need to do is to actually calculate our X to know. Remember that we have two milk mixing, and we've defined this to be 1 liter. We need to know the proportion, at what proportions are they mixing. How much of the X are we mixing with the 1 liter to actually give us the 2% butterfat? So for actually, let me just write it down, that calculate the value of X, which is the volume of the no-fat milk. with 0.6% butterfat. Yeah, so that is it. So that's actually our first step, and if we're going to be doing that, then we're gonna need to do our butterfat balance. Let me just write here that butterfat balance, we know that it's 6% here and 0.6% here, and then it results with 2% there. With that said, we're going to say, remember the 2% when we convert it to actually volume base, because remember they say all the information, the percentage is actually on a volume base. So the 6% is actually 6% the volume of the butter fat. So which means when we need the volume of the butter fat in the 1 liter, we're going to be using this. It's simply going to be 0.06, which is the volume fraction. Remember, if you just for as a reminder, if you need the volume fraction, you say 6% divide by 100%, and it will give you that. So we multiplied it by 1, which is the 1 liter, plus the butter fat in here, we know it's 0.006 multiplied by x equals to, this side is 2%, so it's 0.02 multiplied by y. So that is basically our butterfat balance equation. So we have balanced the butterfat here and the butterfat here. When it mixes, it gives us the butterfat there. So the second thing we're going to be doing, we need to do the volume balance. Let me just bring a new page. Let's just say volume balance. Volume balance. Yeah, so let me just write in bracket, there is total volume. So with that said, remember we have this. We know that the volume here plus the volume there equals to the volume there. So which means 1 plus x equals to y. Therefore, 1 plus x equals to y. Therefore, our y equals to 1 plus x. And well, let me just name this as 1 and then name this as 2. So we are actually trying to figure out the volumes, the values of both x and y. And when we have this, we can just simply say substitute 2 in 1. So when we take the x plus 1 and substitute it here, we have 0.06 by 1 plus 0.006 multiplied by x equals to 0.02 multiplied by y. Sorry, it's not y anymore. Remember, we're substituting 2 in 1, so we're taking this one and plugging it in here. So in y, we're gonna be putting 1 plus x. So that is basically our equation. So I can just simplify to say 0.06 plus 0.006x equals to 0.02 plus 0.02x. So with that said, that is actually our simplification, and we can go further to actually simplify and solve for x. So that's gonna say give us x equals to 2.857 liters. This is actually telling us that this volume is actually 2.57 liters. And with that said, if we know this volume, then we know that from 2 this equation, y equals to 1 plus 2.857 and equals to 3.857 liters. So we know now that this is actually 2.857 liters and this is 3.857 liters. And that is basically the chemical engineering part of it. Now that we have that, we're going to be going on our step 2, where we're going to be calculating the cost. Let me just write here the cost calculation. Now that we have the chemical engineering information, we can just now easily go to the cost calculation. Now, with that said, we can just say step 2, calculate the cost of producing 3.857 liters. So we're actually going to stick to the basis of 1 liter here, and then we're going to calculate the cost of producing the total of when you add these two milks, these two volumes. So we're going to calculate the cost of producing which is the volume of this milk here, which is 3.857. And with that said, we can just say cost equals to 1 liter multiplied by 3 rand 30 per liter. Remember, it's 1 liter the full cream milk, and we are told that it's 330 per liter, and it's 1 liter. And then we say plus 2.857 liters multiplied by 180 cents per liter. We know we calculated this to be 2.857, and we are told that it's 180 per liter, but the volume is 2.857, so that's that. Plus, now another thing, now that we calculated the cost of the raw material, we need to add the cost of the packaging and the mixing. And we know that we're going to say that the total, which is 3.857 liters multiplied by 80 cents, and well, 80 cents per liter. Now if you calculate that, it's gonna give you 11 rands 53 cents. So that is basically what is it. And if you can check this, you'll realize that the liters fall off, and you're left with basically just an amount. But the 11 rand 53 is actually the amount that was used to actually produce 3.857 liters. So now if we're going to be calculating the cost per liter, we can just say cost per liter equals to the total the cost per liter is going to be the total fee. It's 11.53 all over the total volume. Remember, it's 11.53 for 3.85, so it's gonna be 3.857 liters. And if you calculate that, it's going to give you 2.99 per liter. So it's going to give you 2 rand 99 cents per liter, which means that in this process, as it goes on, for every 1 liter, it cost the producer 2 rand 99 cents. So that is just the second part. So now that we calculated the cost per liter, remember that they actually are saying that the question is, what is the selling price if he wants to make the profit of 130%? So now we're going to go further to calculate the selling price. We can just say selling price equals to production cost plus profit. So it's actually the production plus the profit. And we know that the production cost is actually 2 rand 99 per liter. And then we know that the profit, he wants 130 rands per liter, 130%. So you can just simply say 299 multiplied by 1.3. And then this gives you a selling price of 6 rand 89 cents per liter. So with this, we arrive at our final answer. So this is basically the price that is going to be used, or rather the price that is going to be charging per liter if it's going to be making 130 130% profit. So thank you for your time. I hope we meet again in our next video.